Okay, folks, here's the next thing that we're going to do. Okay. Um, we filled out a circle like this the other day, didn't we? So we're not going to refill the entire thing, but we're going to look at the next part of it. There's a couple things that I'm going to put in place on here, and this is going to help us out get an idea of where we're headed. We're going to start nice and basic. I want you to know that every single person here, that you're in the same boat. This is brand new, so no question is a dumb question. If I cover something that isn't quite making sense there, then please let me know. This is what we call the unit circle. And the reason why it's called a unit circle is the radius is equal to 1. It's centered at 0, 0 and has a radius of 1. We use the unit circle in order to figure out a lot more trigonometry. Okay? A lot more trigonometry. All trigonometry is based around one idea, and that idea is a squared plus b squared is equal to c squared. Does that look familiar? What is it? All trigonometry is based around the Pythagorean theorem. They're like, well, why, Mr. Gens, are you talking about the Pythagorean theorem and then a circle? For those of you who had math for college with me, we talked about the formula for a circle. It was x squared plus y squared is equal to r squared. Do you kind of remember we talked about that? Look at this right here. Does that look familiar to the Pythagorean theorem? They're the same stinking thing. So if the radius is 1, then the formula for the unit circle is x squared plus y squared is equal to 1. And there's all sorts of things that we place on the unit circle. For example, this right here is 0 degrees. This is 90 degrees, 180 degrees, 270 degrees, 360 degrees. I'm going to put a couple other marks up here as well. Does anybody remember from yesterday how many radians is 180? Do you remember the radian measurement that goes over here? Pi. Do you remember the radian measurement that goes here? Pi over 2. Very good. The radian measurement here is 0 or 2 pi. Do you remember what the radian measurement is down here? 3 pi over 2. And then we have all sorts of these other ones as well. I'm just going to identify one of them. I'm going to talk about this one right here. We said that that's 150 degrees. And when we converted it to radians, we said that it is, in fact, 5 pi over 6. What we want to teach you today is actually a coordinate location. So the radius is 1. And so if I go from here to this spot, this coordinate location, or what we call a terminal point, this coordinate is 1, 0. Can somebody tell me what this coordinate is right there then? 0, 1. Can somebody tell me what this coordinate is right here? -1, 0. Can we tell me what this coordinate is right here? 0, -1. That's the basics. Can everybody see how we got the coordinates that we did? Is there any question how we got those? Okay, your goal between today and tomorrow is to figure out this question, which is much more difficult. What's that coordinate? Okay, Zelly's exactly right. It is negative, but it's not -1. Would you agree that it's going to be shorter than -1? And we don't know how high we go. That's the big question. We want to be able to figure those out. It is really important. It is something fundamental for trigonometry. So let's go ahead and investigate that. This will be a 2-day lesson, okay? So we'll do some work today, and we'll be able to get to our practice tomorrow. In order for you to understand this, we need to be able to remember some geometry. Raise your hand if you feel like you don't remember that much geometry. Raise your other hand if you feel like you've somewhat suppressed geometry, like it was an experience that you were, okay, very good. I understand. A lot of people maybe don't always enjoy geometry. My daughter, she's in high school now. She's in Owatonna. She's a ninth grader. And the other day she was asking me about geometry. And she said, yeah, a lot of kids at my school don't like geometry either. Okay? So, very good. There you go. Special triangles, a 30, 60, 90. Here's what's great about a 30, 60, 90 triangle is it is exactly half of a 60, 60, 60 triangle. What's true about a 60, 60, 60 triangle? All the sides are the same because it's an equilateral triangle, right? So look at what happens here. A 30, 60, 90, we slice it in half. So here's what you want to think about, and here's the important part that you're able to think through right now. Okay? Suppose that this had a length of 8. Then what would be the length of this short side here? Why? Because you cut it in half. Everybody see that? Then there was a special way in which we went from this side to this side. You multiply by a special number to get from here to here. Do you know what that was? You could, and if you did, it would just come out to be 4 square roots of 3. So, Soup, you are 100% correct. You could use the Pythagorean theorem, or just every time you could look at this short leg and just multiply it by the square root of 3. Every time. So we'll try one, and we'll see if you guys can figure it out, and we'll do a couple. I'm just trying to drive the point home, okay? So suppose that this was 10. What would this side be? 5. What would this side be? Isn't that nicer than just doing the Pythagorean theorem every time? Trust me, if you do the Pythagorean theorem, it'll come out every time, just like that. I'm going to switch it up here. Suppose, instead of that, suppose that I give you this side, and this side is equal to 3. Then what's this side? 6 doubled, and then this is 3 roots of 3. That's it. You good with that? We had another special kind of triangle. What special kind of triangle do we have other than 30, 60, 90? 45, 45, 90. Nice job. So we got the 45, 45, 90 guy. What do you think is true about a 45, 45, 90? Two sides are the same because they're isosceles. Very good. So, E-ball's on fire. If this side was 9, what was this side? 9. Now, do you remember what you do to get to the hypotenuse? You multiply by another special number, root of 2. Okay, now this is the important one, folks. Focus here for another minute and a half till I get done with this guy, and then it'll kind of make sense all the way through. I got to change a couple things so you can make a prediction. Suppose that this was 4, then this would be, and this would be roots of 2. Okay, you got that. Suppose I change it, and instead of that, I make this so that it's this is going to be 10. So, or I'm sorry, 10 roots of 2. So this is 10, and this is 10. Good. What if I do this to you, though? This is where generally people freak out. This is 5. In order to go from this side to this side, you multiply by the square root of 2, correct? So if I want to go from this side to this side, I have to divide. So you get 5 divided by the root of 2. Can you have the root of 2 in the denominator? What do you do to get rid of the root of 2 in the denominator? And when you do that, you get 5 roots of 2 over 2. So we get 5 roots of 2 over 2. Now, We'll do that again eventually. We have one more triangle, and you've actually seen it before. This one just called a 60, 30, 90. Same kind of properties. I just want to make sure you remember what we talked about before. I set it up. That side is 14. Tell me another side. Which one? Bottom one, 7. What's the other side? 7 root of 3. Good. It looks like you got it. It looks like you're ready to go. Is that a nice little review for geometry? Okay, so here's our goal now. We're going to start with pi over 4. I'm going to flip back to this front here. Who remembers what pi over 4 is in terms of degrees? 45. So here's what we're going to be doing right now, folks. We're going to take this pi over 4 or 45 degree spot. We're going to figure out what that coordinate is. Just like this has a 1, 0, and this has a 0, 1. We're going to figure out what that coordinate is. Okay? And again, it's a 2-day lesson. It's new stuff we're going to be thinking about today. We're going to be practicing a lot of it tomorrow. What? Well, I might be able to give it to you, but without a doubt, you would just be doing it tomorrow. So just one assignment between today and tomorrow. We have to see where we get. I don't know. My guess is I'll just hand it to you tomorrow. We'll actually do a few problems together, and then tomorrow I'll actually have you guys in groups do a problem with me. But I have to see that everybody in the class can do this. That's how I operate with some of this stuff. So let's do that. Everybody agree it's 45? So we'll flip back to this side, and that's what I'm going to do. If they tell you find the terminal point for t is pi over 4, what that means is we have a 45-degree angle. Now, we're working in the unit circle. If we're working in the unit circle, what's the radius? 1. So that means that this has a length of 1. This will always have a length of 1 in the unit circle. You good? Okay. Does everybody see we have a special right triangle? It's a 45, 45, 90. What did we do to get from the leg to the hypotenuse? Leg to the hypotenuse. You multiply by root of 2. So if I'm going to do from the hypotenuse to the leg, I divide by the root of 2. So I take 1 divided by the root of 2. Can't do that, so you multiply top and bottom by, and I get the root of 2 over 2. If that side is the root of 2 over 2, then what's the other side? Root of 2 over 2. So what we're trying to find is the coordinate. And the coordinate is composed of 2 values, the horizontal value and the vertical value. What's the horizontal value? Root of 2 over 2. What is the vertical value? Root of 2 over 2. Excellent. Now we're going to continue to practice that. That's the idea. If I flip back to the front, this coordinate right here is root of 2 over 2, root of 2 over 2. Now, who was it? Morgan spoke up, okay? Because when she saw this point here, she said, no, it can't be -1. It's got to be less than 1, right? Because 1 would be all the way to the side. If you turn those into decimals, it's 0.7071, 0.7071. So if you look at it, does it look like that makes sense? It's a little bit over halfway, a little bit more up than halfway. That's what it is. And you need to come up with those exact values. That's our goal. No. I just gave you guys, I want the exact value of the root of 2 over 2. I gave you the decimal so you could help understand where it's sitting, okay? So for today, what we want to do 3 more examples. It'll go quicker now, and then tomorrow we'll practice it. But this is the meat. If you guys can do this, you're in really good shape, okay? We'll try the next one. 4 pi over 3. Oh my gosh. How many degrees is that? How'd you know it was 240s, Ellie? You looked at the, look at the front page. Attaboy. All right. If you want to convert it, remember we multiply by 180 and we divide it by pi. What happens to the pi's? They cancel. 180 divided by 3 is 60 times 4 is 240. So good job. Now, we're just going to add a little bit. Which quadrant does 240 put you in? The third quadrant. And look, I drew a triangle here, which was really nice. And this one, as I draw my triangle, I always draw it back to the x-axis. Always draw your triangle back to the x-axis. Okay? Can somebody tell me how many degrees past 180 did I go? How many degrees past 180? 60. So that tells me I have a 60, 30, 90 triangle. Can somebody tell me now what's the radius of this circle? 1. So how do I get to the shortest side? Divide by 2. So the shortest side is a half or 0.5. Yep. The shortest side is a half. How do I get from the shortest side to the longer side? Times by the root of 3. Now, here's what you get when you do that. The root of 3 times 1/2, I just get the root of 3 over 2. So that has a coordinate. Let's write down that coordinate. What's the x value? 0.5, but I'm in the third quadrant, so negative 1/2. Remember to make it negative because you're in the third quadrant. What's the y value? Negative root of 3 over 2. That's the terminal point. I'm going to put that back on my circle on front. If you want to, go ahead. If you don't want to, that's fine. But I have this spot right here. We said it's 4 pi over 3, otherwise known as 240 degrees. And we now have a coordinate, and it was negative 1/2 and negative root of 3 over 2. We want to be able to find any of these terminal points. 2 more. You guys are in great shape. Can somebody tell me what's different about letter C? It's negative. So let's suppose it was positive. What's 5 pi over 6 in degrees? Let's convert it. 5 pi over 6 times 180 over pi. Notice that the pi's cancel. What's 180 divided by 6? 30 times 5? 150. So negative 150 degrees. So if I go negative 150 degrees, so negative means I go the other way. If I go negative 150 degrees, which quadrant will I be in? The third quadrant. Because negative 180 would be half the way around. How many degrees short of 180 am I? 30. What kind of triangle do you think I have? A 30, 60, 90. What is the radius? Always 1. What other side do I know? The short one will be a half. How do I get to the other one? Multiply by the root of 3, I get the root of 3 over 2. If I'm in the third quadrant, what's going to be true about both values? They're both negative. So what's the x value? What's the horizontal value? Root of 3 over 2. And then what's the other one? Negative 1/2. Do those values look familiar? Guess what, folks? It's going to be the same kind of values that are going to come up over and over again. And I will end this after we do this last one's the easiest one of all. I'll show you all the values that come on up. Last one, negative pi over 2. Pi over 2 is how many degrees? 90. So if I go negative 90, does everybody agree it's going to put me right here? Remember, the goal is to know the point. It's not always to make a triangle. In this case, you don't have to make a triangle. Look at where you are. I went negative 90. What's that coordinate? We already listed it on the front of your page. What's 0, negative 1? If you end up on one of the axes, you could just write it down. It turns out that it works out this way. You get 5 different values. 0 is always paired with 1. 1/2 is always paired with the root of 3 over 2. And the root of 2 over 2 is always paired with itself. Those go together, and this one goes right by itself. You will always come up with those. Just got to know what's paired with what, whether it's positive or negative, which one comes first. You know the other. And that's why, so, Soup, I want you to pick out any of these angles up there. $45 is going to be the root of 2 over 2, root of 2 over 2. And that one's already up there. Pick one that's not up there for me to see. 120, that's going to be negative 1/2 root of 3 over 2. Once you start to see the pattern, you can do it without doing any of the work. It takes people a while to get there. Tomorrow, we'll practice drawing the circles in place with your assignment and getting those. You guys have had the instruction. Good job. Okay? Tomorrow, we'll get to the practice. Good work.